In this video, we will explore shadow paging, an alternative database recovery technique. Let's dive in to understand what shadow paging is and how it works. Shadow paging is an alternative to log-based recovery techniques. It uses a shadow page table and a current page table. This avoids the overhead of maintaining logs. It provides atomic transactions without undo or redo operations. Shadow paging is particularly efficient for read-intensive workloads. On the right side of the slide, there is a diagram that shows the current page table and the shadow page table. Both point to the database, with the shadow page table having a dashed line, indicating that it is an older copy. Let us explore the basic mechanism of how shadow paging works. First, the database maintains two page tables, a current page table and a shadow page table. The shadow page table is a copy of the current page table at the start of a transaction. All updates are made to the current page table. Modified pages are written to new locations using a technique called copy on write. On commit, the shadow page table is replaced by the current page table. And on abort, the current page table is discarded, and the shadow page table remains. The diagram here illustrates these steps over a transaction timeline. Let's walk through a transaction example using shadow paging. First, at the transaction start, a shadow page table is created as a copy of the current page table. This is represented by the begin transaction command. Next, database operations take place where updates are made to new pages, and the current page table is updated. For example, updating accounts to transfer funds between them. Finally, at the transaction end on commit, the shadow page table is replaced with the current page table. Alternatively, you can roll back to discard changes. The visualization shows page tables and disk storage, illustrating how current and shadow page tables are used, and how pages are updated on the disk. Now, let us understand key benefits of shadow paging. There is no logging overhead, which eliminates the need to maintain and process transaction logs. Shadow paging enables fast recovery, with no need for redo or undo operations during crash recovery. It also ensures atomic transactions, guaranteeing the all-or-nothing property through page table switching. Finally, shadow paging enables excellent read performance, which is ideal for read-intensive workloads with minimal updates. Shadow paging also provides natural isolation between concurrent transactions. The visual shows a comparison chart that represents the recovery performance between shadow paging and log-based approach. There is also a table that represents the feature comparison between shadow paging and log-based approach. Let us consider the key challenges of shadow paging. Copy on write approach can lead to significant disk fragmentation over time. It requires additional storage for maintaining shadow copies of modified pages. It is difficult to implement efficient concurrency control with multiple transactions. It leads to poor performance for write-intensive workloads due to page copying. Shadow paging requires periodic cleanup of unused shadow pages to reclaim space, which is also known as garbage collection. The graph in the slide illustrates relative overhead of using shadow paging and log-based recovery. The resource usage comparison also shows the percentages of disk space, input-output operations, and CPU usage. Let's summarize the key takeaways about shadow paging. Shadow paging is an alternative recovery technique that avoids traditional logging. It uses dual page tables, the current and the shadow page tables, for transaction management. It provides instant recovery with no redo or undo operations. Shadow paging faces challenges with fragmentation and write-intensive workloads. Shadow paging is ideally used in read-intensive database applications and systems requiring fast recovery after failures. The diagram on the right highlights key aspects such as no logging, fast recovery, the use of page tables, and the copy on write mechanism. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.